Determine the derivative of f of x equals root x plus 2x at x equals 4 using the definition of the derivative. All right. Well, first off, we'll call this f prime of x, okay? And the definition of the derivative says that if you have the limit as h approaches 0, you're going to take that limit of f of some x plus h minus f of x all over h. So what we really need to do is we need to find out what f of x plus h is, right? And we do that by replacing every x with x plus h. So you become the square root of x plus h, like that, plus 2x plus h in parentheses. And then what we can quick do here is we could just quick distribute that 2, bada bing, bada bang, and then we get plus 2x plus 2h, like so. All right. Once we do that, we now have enough information to plug stuff in and do a little bit of math and see what happens. We know what f of x is. It's u. Okay, we just found f of x plus h. It's there in red. So let's take the limit as h approaches 0 of root x plus h plus 2x plus 2h minus parentheses root x plus 2h all over h. Now the issue is we don't want to plug in 0 for h because then we get something that's undefined. You can't do it yet. So we need to see if we can work some magic. First off, we can distribute that negative right there. And we get the limit as h approaches 0 of nothing changes yet, root x plus h plus 2x plus 2h, so nothing has changed quite yet. But then we can do minus root x minus 2x, and that's going to all be over h. So usually when this happens, we expect things to disappear, and that's exactly what's going to happen. So the 2x and the 2x disappear. So we have the limit as h approaches 0 of the square root of x plus h plus 2h minus root x. It's supposed to say minus root x all over h. Now what I'm going to do is I'm going to group the radicals together. I'm going to group the roots together, and I'm going to split this off to the side and simplify it a little bit. So I'm going to keep this as the limit as h approaches 0 of the square root of x plus h minus root x plus 2h all over h. Now watch what I do. Notice how I split these guys up. I can now do that, and that leaves me with the limit as h approaches 0 of root x plus h minus root x all over h. Now I'm going to leave some space here on purpose. You'll see why. You just become plus 2 all as well. Now the reason why I'm leaving space here is I still can't plug in 0. Nothing great happens. But what I can do is I'm going to multiply the numerator and the denominator by the conjugate of this guy to have difference of squares thoughts. Okay, so if I multiply u by root x plus h plus root x all over root x plus h plus root x, this is what happens up here. Okay, when you FOIL this guy out, you have root x plus h times root x plus h. Okay, so let me write this over here. Root x plus h times root x plus h is x plus h, right? Then you multiply these guys together, and I'm just going to be a little lazy with my words. This times that minus that times this means you're multiplying the same exact things together, and then they're going to disappear. That's the point of this. The middle guys are going to disappear. So if you're foiling this out, the O and the I go away. They cancel each other out. God is good. And then you have negative, or minus rather, root x times positive root x, which is just minus x all over h. Okay. Now, not h. I take it back. It is all over h, but I still have to factor these guys out. So what I'm going to do is I'm going to keep that h over here and not factor it out. I'm sorry, distribute that out. Root x plus h plus root x. Now, plus 2 is hanging out over here. These guys cancel each other out. So since these guys cancel each other out, we're left with just an h up here over h times something. Now the h's cancel out. How about that? So we have the limit as h approaches 0 of 1 over root x plus h plus root x plus 2. Now I can plug in my 0 and get 1 over, you cancel out, root x plus root x, so 2 root x plus 2. Okay, when I plug in 0 for 2, nothing happens. Not done quite yet though, because I have to plug in 4 to root x or to regular x. That's going to be 1 over 2 times root 4 plus 2, which is going to be, I'm out of space, 1 over 2 times 2, so 1/4 plus 2 is 2 1/4. So kind of a messy problem. Not the prettiest problem in the world, but yeah, that's how you do it. Gross stuff. F of x equals x cubed minus 3 over x, and f prime of x, oh, it gives me the derivative, equals 3x squared plus 3 over x squared. Find the equation of the tangent line at x equals 2. So this is some kind of weird function, and my job, I don't know what the function looks like, but my job is to find the tangent line at some x equals 2. And now this might be a completely inaccurate drawing, but that's fine. I need a straight line that has a slope of the tangent line and goes through a specific point. So what we need is, if we're thinking y equals mx plus b thoughts, which is what I'm going to do, what we're thinking is we need a slope. Well, the derivative gives us slope. So what we're going to do first to get my slope is we're going to take the derivative, which was given to us, and we're going to plug in 2. So the slope is going to exist at f prime of 2, which means 2 times, oh my gosh, 3, oh boy, 3 times 2 squared plus 3 over 2 squared. Ugh. So that's going to be 3 times 4, which is 12, plus 3 over 4, which is 3/4, so 12 3/4. Okay? And if I wanted to, I can make that 51 over 4. Maybe we'll do it that way. Okay? Now we have our slope. What I don't have is I have a y-intercept. I don't even have a point. I have part of a point. So the way I find the other part of the point is I take 2 and plug it into the original equation to get the y value of my point. So let's quick do that. F of 2, not f prime, but f of 2 is going to be 2 cubed minus 3 over 2, which is going to be 8 minus 3 over 2. So 8 minus 1.5 is going to be 6.5, so 13 over 2. So now I'm kind of thinking, I don't like slope-intercept form anymore. I'm going to go with point slope because I can. Point slope is y minus y sub 1 equals m times the quantity x minus x sub 1. So I'm going to go that route. You're my m. My point is going to be x sub 1, y sub 1. You're my x sub 1, and you're my y sub 1. So if I wanted to turn all of this information into that, I would have y minus 13 over 2 equals m, which is 51 over 4 times x minus 2. Now I did point slope form because I'm lazy and it's easier and I'm out of space. If you needed to turn in that into slope intercept form, then you would do some distribution, you would add 13 over 2 to both sides, and it would all work out in the end. But you know what? This is my problem and I'm doing point slope form and you can't tell me what to do. Which of the following gives the derivative of the function f of x equals x squared at the point 2, 4? Well, by definition, the derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. So h approaches 0, which eliminates u. You don't even have a limit, so we're getting rid of those guys. Okay, now f of x plus h means I'm going to take f of x and replace every x with x plus h. So you become x plus h squared minus f of x is just x squared, so x squared all over h. And it's the limit as h approaches 0 of that. Now, I could take this one step further because they want me to use the 0.24. Okay, I only care about the x value. So this is going to become the limit as 2 plus h squared minus 2 squared all over h. Which, looking at my options, appears to be u. Okay, so kind of a weird problem. You don't have to do too much. You just have to set it up. And yeah, we're done.